Hello everyone, welcome back to a new episode of Advent of Code. Today we're going to be doing problem 7. As with yesterday, I read this problem statement off camera before I got started while I was having dinner. And I gotta say, I'm glad I did, because it took me several read-throughs to understand what the heck they were actually asking for. So I'll give you guys the short version after I read it over. Day 7, Amplification Circuit. Based on the navigational maps, you're going to need to send more power to your ship's thrusters to reach Santa in time. To do this, you'll need to configure a series of amplifiers already installed on the ship. There are 5 amplifiers connected in series. Each one receives an input signal and produces an output signal. They're connected such that the first amplifier's output leads to the second amplifier's input. Second amplifier's output leads to the third amplifier's input, and so on. The first amplifier's input value is 0, and the last amplifier's output leads to your ship's thrusters. The elves have sent you some amplifier control software, a program that should run on your existing Intcode computer. Each amplifier will need to run a copy of the program. When a copy of the program starts running on an amplifier, it will first use an input instruction to ask the amplifier for its current phase setting, an integer from 0 to 4. Each phase setting is used exactly once, but the elves can't remember which amplifier needs which phase setting. The program will then call another input instruction to get the amplifier's input signal, compute the correct output signal, and supply it back to the amplifier with an output instruction. Right. If the amplifier has not yet received an input signal, it waits until one arrives. I still don't really understand why that's specified, but okay. Your job is to find the largest output signal that can be sent to the thrusters by trying every possible combination of phase settings on the amplifiers. Make sure that memory is not shared or reused between copies of the program. So, I got really confused about these, the amplifier numbers. And I was trying to figure out, and they're like, oh, it wants its input setting or something, and I don't know. I couldn't figure it out. But eventually I realized, the long and short of it is, each of these amplifiers gets fed one input. One of the inputs, we run the program 5 times, right? Each time feeding it 2 inputs. The first input we have no choice about. It's either 0 if it's the first amplifier, or the output of the previous amplifier if it's one of the later ones. The other output is one we do have control over. We have to, when we run the program 5 times, pass each of the numbers from 0 to 4 one time each. But we get to choose the order, and we need to do a little optimization problem over the, what is 5 factorial, right? It's 720? No, 120. So there are 120 possible, easily brute forceable, right? 120 possible solutions we need to explore, and we just need to see which one is best. And we don't have to adjust our Intcode computer at all for this yet, which is interesting. So I decided, actually, I had talked about setting up my Intcode thing as a library. I decided not to do that after all. And I'm just actually going to, even though it seems gross, copy this into each day's puzzle as a library that I copy and continue modifying. One reason for this is that I did not want... I want to be able to make compatibility breaking changes to the library. And so, I don't want to break previous day's solutions because I've updated the library to have a different type signature or something. So I want to have every copy of the library checked in so it's all runnable anyway. So I'm just going to give each day its own copy. And this way it'll be easier to view the evolution. Actually, maybe it's harder compared to git log. All right, so this is all set. And we just need to refresh our memory on what are the interesting... These are the only functions we care about from Intcode, right? Make computer, tick, and run to completion. And we're just going to compute all the permutations of the integers 0 to 4 and fold over each of them, basically. So one thing I want to know is like Haskell permutations. Is that like in data lists or something? Data list, yes, okay. So that's great. Advent.intCode. So the first thing I want to know is, does this actually work? No. Oh, yeah, that's true because I didn't update the module name. You got me on that one. And after I do this, it still won't work. Oh, I didn't add it to my cabal file. Sure. So I need to kill the cabal session anyway. We'll grab the input here. Yes, lots of warnings. I know. So now when I load this and load this, all right, I don't know. I give up. I'm quitting Emacs again because like I'm pretty sure that's how the modules are supposed to look. I don't know. Yeah, see, it works. It's just like if you ever load something with the wrong module name into this Emacs tool, it just like stays broken forever. Okay. So we want import data list permutations. Our input is a list of. Actually, what type do we give this in int code? It's a list of int, so I guess that's what we'll use here. List of int. And honestly, let's just go grab the parsing. You know what? I should put the parsing code into the int code library, right? So right now it's here. I guess I should go about here. Parse int code program takes a string and produces a list of int. And honestly, we should maybe give this a type alias as well. Call it like program or something. I guess we need data list split here. Ugh. I'm gonna have to restart Emacs again, aren't I? This is what I get for like generating the template cabal files ahead of time. Is that now I have an old template lying around and I don't really want to update all the future ones. Wait, how come you were willing to accept that? Wow, are you willing to do that? Just give me split. Yeah? Yeah? Sure? Did it actually work? Oh my god, it did not work at all. That is completely the wrong definition of split. I don't know, guys. Let me see if it made even the right changes to my cabal file. Yeah, that's right. Wild. Oh, I called it split on. Oh, maybe that's why I was getting the wrong highlight. It was getting split from somewhere else. What? What are you talking about? Programs? Oh, this is now I'm finally using the wrong read. Okay. But didn't it like fail to compile? Oh no, it's using the read from here. Got it. Now when I give it the right read, it's perfectly happy. Okay. So, back to our main. It's a program, I guess. And prepare is just parse encode program. Okay. So part 1 of P equals do. That seems fine. Phases, permutations of 0 to 4. So we'll choose an arbitrary permutation, and well, let's actually say maximum of do, and give me maximum's in data list, right? No, maximum's in prelude. Maximum by is in data list, I think. Now let's see. What kind of fold exactly do I want here? Well, so I need a... I think a fold L is fine, where the initial value is 0, and each time I like run the program and look at its output. Yeah, so fold L. Oh, but it's not quite a fold because the function changes every time because the phase I'm using is going to be different. I kind of need... I need to fold R over the list of phases. Fold L over it, I guess. Yeah. I'm folding over the list of phases. And at each step, the first input to run is the phase I'm on, and the second one is the accumulator, which starts at 0 and then becomes the step of the program. Okay, so fold L, run amplifier 0 phases. I think it's actually just like this, right? And I need to define run amplifier. Run amplifier of, let's see, our accumulator is first, so this is the phase, and then the input equals, oh, hang on, program. So what order am I supposed to supply the inputs here? It first asks for the phase setting, and then it will ask for its input signal. Okay. So what we need to do is, let's look in int code, and what do I have? I have make computer, and I have run to completion. I guess either string or int is what I have here. And it's a fold LM, actually, I think. Haskell fold LM, fold M, fold LM. What am I looking for exactly? Probably in control monad. Fold M is like fold L. Okay, so that's fine. Import control monad fold M. Not fold LM. Fold M. Run, I guess. Wait. No, the fold's going down here, silly. Fold M. Okay, we don't need to do any kind of folding here. Is that right? What's going on? So I was thinking, like, we're getting back an either every time, right? Yeah, and that's fine. So our function takes a b and an a and returns an mb. Here m is either string, and we get an either back as a result, but we don't have to like wrap anything in pure to begin with or something. Okay, so run amplifier p. Well, let's give run amplifier a type, shall we? It takes a program and an int and an int and produces an int. No, an either string int. Is this type check? Almost. Yeah, that's fair. We are getting back a list of either string int. Wait, run amplifier. Yeah, any one of these running programs could error, but it shouldn't. So I guess we want to we need to sequence this to turn our list of ethers into an either of a list, basically. There. Fmap maximum, then seek. Yeah, okay, got it. So now this run amplifier program function is pretty simple, right? We say run to completion, make computer a list of ints. I've already forgotten what order we're supposed to give the inputs to this thing in. It will first ask for the phase setting. Okay. So phase input is the inputs we're giving it. We have to supply the program first. I should really change the signature. Excuse me. of make computer to take a program, which I guess in fairness is just the program's memory, right? They're kind of the same thing, but okay, whatever. It's clearer now, I think, to me. So this run to completion make computer program, right, like this type checks, yeah. Run to completion, of course, does not, because we get back this, and we need to write like head outputs, like so. That is redundant, I guess, but I really can never remember like what the relative precedence is of like composition and fmap. But okay, like okay. So like maybe this just works. Who knows? Should be fun to find out, right? Invalid input. All right, fair enough. What is that? What does invalid input mean exactly? I don't remember this anymore. Okay, so what is it printing here? It's printing the inputs and then the parameters. So it's noticed that I've tried to input when there were no input values left to read for some reason. Okay, possibly. Price phase setting. Is it possible that like the encode program is intended to crash at some point? I don't think so. I'm like, I have not left myself any kind of like ability to debug things at all. What a mess of a program. Yeah, we can make this left now at least. No? Oh yeah, because it's I don't know. I don't want to mess with that. I mean, we can look at the encode program a bit, but I bet it would make more sense to like try one of the example inputs. Right? So like this is a pretty short program. We could maybe even figure out by hand how it's supposed to work. So part one is taking, yeah, it takes a program. So I can just like, I can run this in the REPL. Part one of like this. It says 100. I got a value back. That's nice. Was it the right value? Not even close. Right? I fed it this program. And it's supposed to have produced 43,210. Uh-huh. I mean, the good news is all of the program, every copy of the program ran successfully on this input. That's an improvement. I mean, we can try running like even more. We can say just run it on 43210, right? I guess. Like run amplifier of this this and a phase of... Oh, that's not quite right. Well, we could do it by hand, in fact. Phase 4, an input of 0. We get 4. And then run the same thing with a phase of 3 and an input of 4. Right? I mean, this is... It's not really, I guess, going to tell me... 4, 3, 4, 3, 2. This is actually looking exactly correct, and it suggests that I might... Okay, so actually, that's very reassuring, in a way. It means that run amplifier is completely correct. Or, well, yeah, it must be, right? So something is wrong with part 1 that causes it to break. Like, it, even ignoring the fact that the encode program crashed, part 1 is, like, clearly doing the wrong thing. How could this be? Come back. So, buttons are hard. So we could say here, foldem run amplifier of this 0, and then the phases we want is 4, 3, 2, 1, 0, right? And this should give us back 100 for like no obvious reason. Yeah. Okay, so at least we weren't like handling the phases wrong, but something's weird here, right? Foldem. Okay, I bet what's happening is that foldem takes its arguments in the other order than I thought, right? Or the function that foldem wants, right? So t foldem. So it produces an MB. So it wants the accumulator first. That seems correct. That's what I wrote, isn't it? No. Boop. So that's the problem, I think. Yeah, now we get 43210. Okay. So if I run main, I get an actual number this time. Got it. And that's what we're supposed to write, the highest signal. Not like how you get the highest signal or something. Great, that's the right answer. I edited day 6's main? I don't remember why. Oh, I just like didn't commit this change after I was fooling around with stuff? Okay, whatever. I mean, I guess that's an improvement, right? Oh, you guys can't see. Day 6 cleanup. It's not very interesting. I just like, I put this paths in to debug something weird, the type for paths in to debug something weird that was going on, and then I realized I didn't need it. And then later I realized, oh, there's an extra blank line here. So now that's committed. Okay, back to the problem. It's no good. In this configuration, the amplifiers can't generate a large enough output signal to produce the thrust you'll need. The L's quickly talk you through rewiring the amplifiers into a feedback loop. Most of the amplifiers are connected as they were before, A into B, and so on. However, the output for E is connected into A's input. This creates the feedback loop. The signal will be sent through the amplifiers many times. In feedback loop mode, the amplifiers need totally different phase settings. Integers from 5 to 9, again, each used exactly once. These settings will cause the amplifier controller software to repeatedly take input and produce output many times before halting. Oh no. Provide each amplifier its phase setting at its first input instruction. All further input-output instructions are for signals. Don't restart it. Yeah, so... all signals sent or received will be between pairs of amplifiers, except the very first and the very last. 0 is sent to A is input exactly once. Yeah. So... God, I don't want to do this. This is like exactly... I remember 2 or 3 years ago when he extended like the kind of program simulation thing to be a multi-process kind of simulator. It was just like a lot harder. And I think that was like when I gave up on that month. It was just like I didn't keep doing it. I spent a lot of time debugging that and like never really got anywhere. I'm not like giving up immediately here, but like what would we need to change int code, obviously, right? Even though we have like we don't have to use run to completion, right? We can just use tick. But the problem is that actually, I think this isn't too bad. I was thinking it's a little bit hard. I mean, it's like not great, but I was thinking it's hard to run the program until it needs an input and then like detect that it doesn't have an input. But actually we can do the opposite. We can run the program until it produces an output, then suspend the program and move on to the next one. Right? So maybe I should have written run to completion to be like run until condition. Something like that. Well, let's do that, right? Run until condition. By this, what's eventually it will halt. The last output signal is sent to the thrusters. Oh, this is a little tricky, isn't it? When the final program halts, we don't know where to send the output signal. Because if the program asks for an input again, we need to go, oh, okay, yeah, got it. Let me go feed your output to amplifier 1 and start the loop over. But if the program outputs something and then halts, then we're done and we need to send its output to, well, but on the other hand, the amplifier E, when it stops, A, B, C, and D will already have stopped also. So in principle, we could use that to determine when when the process is finished. But I think it is actually cleaner to run until it needs input. And that way we don't have to do anything weird. We just like run until it's either halted or needs input. And then when we get to E, if it's halted, we output the value. If it needs input, we go back to A and start over. So run until condition takes a computer. Let's say it takes a computer to pool first. And drop while not run until condition done. Done isn't quite right, is it? We'll just call this predicate, and then we'll make a new function called done. Where done true and done of right C is pred C? Why is this lit up? Oh, because predecessor? Yeah, I don't care. So run to completion is just run until condition not running. I forget what running means. Oh, that's right. Left is if the program crashes. Normally, it completes normally and just says, I'm no longer running. Produces a right value where the computer has false in this slot. So that's the termination condition we should actually expect, not them turning into lefts. That should be impossible. One thing that occurs to me is that like it's not so easy to write a condition for blocked on input, right? Let's put that in int code. Needs input is a function from computer to pool. Needs input of C is, first of all, that inputs of C null, well, there are no inputs left, and decode next of C. Produces an instruction mean, I guess if it needs input, we should say if we fail to decode the instruction, let's just say it's not blocked on input. It is like royally effed. And otherwise, if it is an instruction whose operation so the opcode of the operation equals, and I know I could case, maybe I should. An operation true. Oh, and then I can say in all other cases you are not blocked on input. This type checks, so I must have the right number of underscores in. Right, so this is the idea. If the program currently is about to run an input and there are no inputs, then we say that the program is blocked on input. Now, what does the loop look like that main is going to run? It needs a list of computers, right? I guess. And the condition that we want to give is either that it is not running or it needs input. And if it's, yeah, okay. So we have a list of computers and a carryover input from the previous phase, right? Which is 0 for phase for like the very first time we've run it. And a step of the algorithm is to run each computer until it is either not running or blocked on input. And feed them into the next, saving the computers that we get as a result. What is the name of that function? So we want to run... I mean, it's kind of just a full dar, but not really. It's not a scanl, is it? I think it is a scanl, actually. No, because we need back the... We need back the program and its output. I mean, we don't, right? The program has, as part of it, its output. But we need to, like, get a view of the program that doesn't have an output. Well, no, we don't even need that, do we? We can take the view of the program that had an output and, like, later just overwrite it with the new output? New, like, input to give it? When we can just leave all the outputs visible in the computer. Who cares? They're just getting added on to the end. I don't mind. So, but the problem is that scanl doesn't give us like the list items back, right? It gives us back the accumulator, and well, and it passes the accumulator to the next step of the function. We can have the accumulator be a program, even if all we care about in that program is its last output value, right? So it seems like a scanl should work here. So let's just kind of write this stuff in part 2 and then extract it out as necessary. Part 1 of program. Let's see. We do something pretty similar here. Fmap maximum dot sequence of do, like we can write all this and that's fine. Phases, permutations of 5 to 9. Right, that's what we're supposed to use. Yeah, 5 to 9. And then we can just say pure of run feedback of P and phases. We need to implement run feedback, but like we've made some progress, right? Run feedback. It'll even tell me what type it has, which is, right? It should. Unexpected response. Really? Yeah. Standing for W? Why isn't it an int? Or P and phases all have fixed types. Shouldn't it be able to infer what type this should have? I don't know, whatever. It doesn't really matter. I know what type it should have, and that's good enough. Run feedback. I just thought it would be fun to put a wildcard there, but apparently not. Run feedback is a function taking a program as an input and a list of int representing the phases you should run, and returning either a string or an int. So first we need to set up n copies of the program, which is pretty simple, I think. Let amps equal make computer p phases p phase make computer just takes those two arguments, right? Oh, but the well, yeah, actually this is about right. I want to give them just a single input and have them run until they want another one. And I'll just have, then they'll be already in good shape to accept the carryover, right? Okay, for phasing phases. In, I guess. I guess run till done, we'll have to define this, of 0 are carryover and amps. Right? Why is it mad about phase and phases here? Oh, there we go. So run till done is a function that tracks like the carryover input and the set of programs, right? The set of amplifiers. Where run till done of carry, I'll call it the seed, why not? P's equals. So at this point, we have decided that we are going to run the programs through another step. And we have a list of programs, or a list of computers, not like either string computers. So we know they ran successfully in the previous phase. So we just need to make sure to keep that invariant when we get to the end of run till done. And now I just still don't know exactly what fold to write here. Am I just going to write recursion by hand? It's so gross. I know there's some higher order operation that expresses exactly what I want to do here, but I don't really know what it is. Go. Where go of... No, this isn't even that useful. I need to do it kind of the opposite, actually, I think. Seed P's equals go of... Well, there's nothing useful to do here, is there? Okay, maybe I just do some pattern matching here. I say if I have no programs, well, this can't be right. I obviously need more programs. Do I? Maybe not. If as I traverse the list, I produce more programs as output, I can rely on myself recursively to have produced those. Maybe let's write the base case later. So we've concluded there's at least one program and we have a seed to give to it, right? So let's say case run until done of P, but the inputs are slightly changed. Inputs, what did I call it? Inputs equals seed. Not run till done. Run until condition done. Done of C equals lift a 2 or needs input not running. So a program is done if it either needs input or is not running. Yeah, and that type checks. So if we get a left, we're pretty sad. and we can just return it. So I guess that means really we're just implementing a weird bind, but okay, whatever. I'll just write it all by hand because I'm too dumb to figure out the right abstractions. Write C. I guess I should call these C, not P, but whatever. So now we have a program that needs input. You know, so I can obviously like extract the output from this. That's fine. And then extract the computer as well. I'm just not sure exactly like how to get that computer to the next step of run until done. You know what? It almost feels like what I need is a writer monad so that this fold can emit the computers that still need more steps, which I assume will be all of them or none of them. And yeah. Yeah, this is like a fold M in the writer monad, I think, is what I'm doing here. But it's like writer T combined with error. Ugh. Because I have the option to exit early as well. I'm just like not fancy enough to do that at 10 p.m. 10:30? Ugh. But the fact that I've realized that what I basically want is writer makes me see how to do it by hand because I know how writer works. Which is that I should return a tuple of the computers still remaining to run and the current seed. Wrapped in a write, of course. So this computer, in fact, well, okay, let's see. We know that we definitely need to run all the remaining computers with the input from this one. So let's just do that. Let afters and new seed, I guess. Yeah. Equal run till done of C, no. Of the so we're going to give it the output from the computer that just finished. And P's. Uh, what do I do if I get to the end of the list, right? When P's is empty. I guess that's... The base case is just like, I don't know. I guess I can just return like the seed I was given and an empty list, and that should be fine. Oh, I can't do a let because run till done returns an either, right? Yeah. Case of... God, what a terrible, terrible implementation. Left... that was so bad. And so if there was... I think I can actually just return this. No, I have to add C into after, the list afters, right? Right of something like this. So run till done. As I've written it, I think is just run one step. It runs all the computers, feeding their input into each other, and gives back finished, like updated computers for each of them and a new seed. So it's not really run till done, it's run one step. But we actually want to be a little bit where remaining, if C is running, then remaining is C afters, and otherwise it's just afters, which I expect to be empty in any case. But right, if the computer doesn't want an input, it's done, then we shouldn't put it back in the list. And eventually, we'll run one step, we'll return a tuple. Oh, I need to import lift A2. So eventually, run one step will return a tuple, which is an empty list, and a seed, and then we get the answer. So this is just an undebuggable mess. So I really hope it works on the first try. Run till done of seed progs equal case run one step of seed progs of well, result empty list, we say pure result. Right, let's call it the carry. P's is run one step, no, run till done of carry P's. Left E is left E. couldn't match type int with computer. Oh, I got these backwards. We're returning the computers first, so it should really be like this. Yeah, run one step doesn't have is pure nothing seed? What are you warning me about here? Binding for P shadows. Yeah, who cares? This is like the worst Haskell code I've written that I can remember. It's just terrible. Because I can't really figure out the elegant way to do anything. I'm just sort of like thinking imperatively, do this, do that, do this, do that. And I'm like, okay, I have to handle all the errors on the way. Right, this is what Go code looks like. Just little tease the Go community there. I'm not a big fan of Go for reasons like this. I'm sure there are good things about it. In fact, I know what some of them are, but it does kind of have this if error return nil kind of flavor, doesn't it? I mean, okay, like, let's just try running it. Like, what's the worst that could happen? It'll be fun, right? Empty list. Sure. Yeah, we probably, like, we ran a program. Well, okay, I guess we should like case outputs C. No. Yes. Result cons to anything. And if it's empty, left no outputs, oh. Well, no, maybe this is fine. It's no outputs in. So, like, I can run this again and maybe learn something. No outputs, and we have this computer. IP is 21. No inputs. It's never produced any outputs. So we ran the first program until it needed an input. Well, yeah, of course it's mad. We gave it one input. Ah. The problem is we're overwriting the phase input we gave it, right? We gave it a phase, but we didn't run it long enough to consume that phase, and then we're overwriting the inputs. So really it should be seed cons to inputs of P. Unknown opcode 0 at offset 9. Well, now that is not so easy to track down. Okay, are there any like example programs we can look at? I mean, yes. I'm not sure I'm going to get a lot of value out of testing this. God, So if we go here and we say like, what do I have in main? I kind of want to say like run feedback. Actually, like run one step doesn't have to be a local function at all. Does it? Why is it mad? Unexpected case expression. Where? Oh, I don't have a where for all this other stuff. Got it. But run one step and done do need to be attached to this with a where. It's still mad. Oh, this all needs to be indented more. Oh, run till done needs to live up here? This is stupid program surgery because there was no reason to even do it. Well, there was. I wanted run one step to be like a top level function I could use so that I could test it. Okay, actually, there's more problems that I see. Is that we need to make sure... No, we don't need to make sure to erase the inputs because when the program reads an input, it erases it. Yeah, that's fine. Okay, but anyway, so run till done. Oh, whoops. Yeah, but now, like, done needs to be over here. There's no type signature. I agree with you. So like run one step is a function from value and list of computer to an either a string or a tuple of list of computer and a value. So now we could, for example, check whether run one step, like this is kind of should be part one, right? It should produce a list of 5 more computers and the result that they would have output, I think. So like, let's go back and test the input from part 1 on this. Run one step takes a value 0 here. Oh, it's a little bit of a pain to produce the computers, isn't it? Okay, clearly it was not in my paste buffer there. There we go. Make computer this phase in 4 43210, right? Is that the right run one step seed list of computer? I mean, it seems, yeah. What in the world? Oh, 100 again. Oh, that's very suspicious and weird. It's exactly the same problem we had before. Are you kidding me? I got the argument order wrong again somewhere? Okay. Okay. But where? There's no longer a call to fold M to mess it up. Right? What? How did I get 100 again? Okay, well, let's do this. How about just give me 4? Produced 40. But when we tried it before, it was giving us 4. Right? 70. So we're producing a value that's 10 times as large as it's supposed to be or something? I don't know. We're adding 20 and then we're adding 10. Yeah, now we're going to add 0. So somehow run one step is messed up. We look at the outputs and we say run one step, the output that the program produced and the seed prime should be the seed that was produced by the last computer. This is just like very spooky because oh wait, run one step, is run one steps broken? No, it looks right because we give the input of 4. Oh, I see. The problem is we feed it the input 0. So the problem is that in every step except the first step, the program has no inputs, and so consing seed onto the front is correct. But in the very first step, the program has an input, and so we're feeding the seed in the wrong order. And so like this is kind of stupid. But doing this, I think actually fixes the ordering issue for the first program and doesn't matter for any of the others. Yeah, now we get 43210. So run one step is astonishingly correct. A large number. That's great news. I love large numbers. Please, please tell me it was correct. It was correct. I'm not a complete, like, joker who can't even write a simple, like, interpreter. But boy, is it a mess, huh? So let's at least clean this up a bit, right? What I should do is take this. Well, what I should do is commit this before I screw it up. And now I should like clean up all these stupid case expressions. Say like, listen, we're running until condition. In fact, oh god, this was all just like a do. Like, okay, this is a little gross, but and now here we again say do. Is this where in the wrong place? Yeah, it is. There is no right place, actually. Well, no, isn't... No, there's not. I see. We can't do it with a where clause now because we don't have a pattern binding to attach to. How about bool id ccons? Afters? What? Bool? Oh, I see. I need to now... I've forgotten what used to be here. Running. Yeah, okay. So if the program was running, then we take the function ccons, and if it wasn't running, we take the function identity and apply that to afters. The effect being that we add a computer to the front only if it was still running. Got it. Now, really, this is like, it would be a little bit nicer probably. If we were taking this tuple in the other order, because then we could just use fmap into the result of this. So we don't actually have to look at afters or seed to decide what to do, right? We could like fmap of this, basically. I don't know. I'm not going to mess with that right now. So we can make this a do as well. P's. Oops. Carry from here. Case P's of empty, then pure carry. Otherwise, run till done. Yeah. So that's starting to get a bit cleaner, isn't it? It's still not beautiful, but it doesn't like look It doesn't like make me want to drive nails into my eyes, right? Spikes. I don't know. So we don't need scanl. That's certainly true. All right. Well, I'm okay with just that small amount of cleanup. It's still not an elegant or well-written program, but it's like okay. Let's confirm that it's still correct. Looks about right. Yeah, okay. Okay, cool. Well, I mean, all things considered, it only took an hour and a half. And that's like not great. But it's fine. Yeah. I'm not like in love with the encode problems this year. They're okay. And I'm sure at the end of the month we'll have a very nice encode computer. But I kind of like the ones where you like have a new problem statement every time. I don't know. Something like greenfield stuff, I guess. Anyway, we're done for today though. Thanks for watching, and I'll see you next time.